Thank you very much for coming to this presentation. My name is Nikolay Pakulin. I'm the Chief Technical Officer of the PEX Data Tech company that is behind development of 컬러플랫폼. In his presentation, Dr. Cho gave you some insights into what 컬러플랫폼, why 컬러플랫폼 is and what is the purpose of it. And in mine, I will tell you a bit more about what it is. So a few words about me. I graduated from the Moscow Institute of Physics and Technology, that is more known as MFTI, in 2000. In 2006, I received PhD degree from Institute for System Programming, Russian Academy of Science on formal methods and verification. And actually, I was with the Institute for 18 years, starting as a student in 2000 and living as a research secretary in 2018 when I moved to CTO in PEX Data Tech in Seoul, Korea. So one of the major challenges that blockchain faces nowadays is that most of them have rather limited performance. And the reason is, I will tell it a bit more, so to show you the motivation behind our design, is that actually blockchain is a mix of data and business logic in one stream. What does it mean? Actually, when a DApp wants to process transaction in a blockchain, they all get in the same pool and wait for the network to process. As CryptoKitties application showed, when there is a burst of activity in the network gets stalled, because actually blockchain might have thousands of nodes, but every transaction is performed by just one computer. If we have a proof of work, it is the computer that won the game of generating hash. If we have a proof of stake, it is the computer that received its turn to be a block producer. So thousands of nodes in the network just degrade to a single computer. So there is no parallel, no concurrent execution. It's a sequential, transaction by transaction, running application. And it means also that the transactions should be small, short, because the longer the transaction, the more time it takes to build the block, and the blocks should go out faster. So there are some rather strange languages for specifying the smart contracts, such as Solidity. Solidity is a nice language until you start trying to develop something reasonable in it. And you may try to write a web server in Solidity and you will find all the limitations of the language. And Vitalik Buterin recently, a co-founder of Ethereum, recently had several tough questions for crypto community. And one of the questions was, why don't we have sophisticated smart contracts? The answer is because it is sequential, it is small. So how people try to solve this issue? Some of them try to produce blocks faster. So the very first blockchain generated, one block per 10 minutes. The next one, Ethereum, 10 to 40, 50 seconds, depending on the on the complexity of transactions. EOS, the newly star, is 1 block per second. Another approach is to produce bigger blocks. Maybe you have heard about SegWit in Bitcoin, off-chain data in Bitcoin and some other blockchains. There are projects when block size might be measured in gigabytes, but actually all of them have the same original sin. They execute smart contracts one by one in a sequential manner, so the performance is actually depending on the time spent by each transaction. So the longer transaction is, the lower performance is. The higher you have the performance, the smaller you must have the transactions. So there is a trap. Either you write something small, or your network will be stalled waiting for the block producer to compute a long and complicated DApp. So how does this is one of the major concerns behind the design of 컬러플랫폼. How do we try to answer this question? So the answer is simple, and it is well known in IT and computer science. We will try to do all at once. So parallel execution, and maybe not just by one worker, but by magnitude of them. As Dr. Cho already introduced, we have a two-layer architecture. The top layer is a computational layer. It performs the transactions in business logic. It is called either logic nodes or service nodes. They are running atop of blockchain. It is not like in all the traditional blockchains when data stream goes first into blockchain that it executes in some block producer, then goes back and burnt as a block. No, it is first executed in some kind of a virtual machine, and there are dozens or hundreds of such virtual machines running in parallel. So this is true concurrent execution, and the block and the network is not parallelized if some of such smart contract is long. They are executed in parallel, so the longer it runs, the later its data will go to blockchain. But before that, faster can produce other data that goes into blockchain and is saved in an immutable sequence of transactions that can be used as an actual history of all the operations in the network. So the technology could be viewed as a multi-tier communication. On the left. On the left, there is a terminal node. It's actually a device where a client-side application runs. It might be a mobile phone, a desktop app, a browser app that communicates through some gateway with the platform, where in the service nodes, the business logic actually executed. So terminal node provides a client side of an application. One of the key points of a terminal node is that it authenticates user with a wallet ID, and it provides secure channel to the network. What's the difference between this approach and existing blockchain? Actually, it is very much the same. The wallet ID and some authentication of each operation that this application generates. But we are going to have higher through output, so more actions, more transactions, and we prefer not to sign everyone, but to establish a secure channel and use JSON for encoding messages. They arrive to the top of this picture, to the application protocol interface and load balancing, and it is being distributed to hosting our infrastructures where service nodes with business logic run. Inside every service node there is a Color virtual machine that is used to host the logic of decentralized application of the DApp. Every DApp needs to save some variables for future. It is implemented using state database. Actually, state database you can find in every and each blockchain except for Bitcoins and its clones. We will provide also storage for keeping files, and a Color distributed ledger that is actually the blockchain that is used to synchronize the state database between different nodes. Actually, from the computer science perspective, every blockchain, even the Bitcoin one, is actually a protocol for synchronizing distributed database. Every node keeps a set of persistent variables, and every change in such a variable produces a transaction that is sent to some network, then other nodes read information about such transaction and update their database. So we can say that most of blockchains, they are reinventing the wheel, because the actual algorithm and protocols for synchronizing databases are as old as 30 years from now, or even longer. The entrance to the 컬러플랫폼 is application interface that implements authentication for every DApp. For every input to the 컬러플랫폼 should be authenticated, because every input is connected to some wallet. So we need to know who originated specific transaction. So security is one of the key points of the system in order to avoid fraud, fake transaction, or stealing transactions from other clients. Very important part of the system is load balancing. Why applications are called decentralized? Because you never know where each application is executed. So from another point of view, every blockchain is a cloud. It is a cloud that provides some infrastructure with resources, and you as a client of this cloud never know which particular node will execute your application. Same is in 컬러플랫폼, but in 컬러플랫폼 we call cloud a cloud. We don't try to invent new wheel. We use well-known technologies for distributing execution and data. And it will also provide the coin transfer API for applications to use the economy. So Color is not just another hosting facility, another cloud. It is also a platform for economical relationships, such as money transfer, money earning, money spending. We have a mission, we produce coins, and we provide the ways for the application developers to spend the money they earn from providing services to users. The cornerstone of the whole technology is actually the state database. Every application needs to keep specific variables between execution. It could be wallet balance, assets that were created, assets that were deleted. It could be ownership transitions across assets, such as in CryptoKitties, there are kittens, and you can sell your kitten, that is you have an asset, and you can transfer the ownership right from one user to another. So it's economy, but in technological point of view, it is saved in some state database. It's part of the state. And the question here is how to synchronize the states between multiple nodes. There are many existing answers in computer science. So we are also going not to reinvent the same wheel once again. We will try existing approaches. There are really dozens of various protocols for synchronizing the distributed databases, such as Paxos family of protocols, Apache, Zookeeper, and so on. So we will try. Our main motto is to use well-known and efficient and proven solutions. So let's take a already existing state database. Let's try to use existing synchronization protocols and use the Color distributed ledger for putting down the major events that happen in the network, such as money transfer, such as creating an asset, such as deleting an asset, such as transfer of ownership rights, so that every important step in the economical sphere of Color coin is fixed, and it could be used, well, to prove some rights, to prove that something happened, and so on. What is important here is what we provide for the apps to run in this system. The environment that wraps the code is Color virtual machine. It's not a new word. You know maybe Ethereum virtual machine. In EOS there is also a virtual machine. So this is an environment that provides execution and services of the platform. What is the weak point with, for instance, Ethereum? Ethereum has a rather strange language as the coding tool for smart contracts. Solidity is unstable. It is its compiling technology is evolving. There are many new features, but anyway, it lacks lots of tools that most developers are used to, and that is why we would like to equip our app developers with powerful programming language such as Java, C++, JavaScript, and not just a language, but all the set of libraries that a developer needs for writing an application. And Color Virtual Machine will provide also connectors for the platform tools such as StateDB, such as storage, such as Ledger, and for communication with the terminal node, cryptography services, and networking facilities. So to summarize the technology advancement of Color Platform, I would say that it is merging the two worlds. One world is the world of distributed computation, like multi-node, concurrent execution, and synchronization over network. And it has the second world, that is the blockchain, that is immutable sequence of operations, that is immutable history. And to do this, we have to rethink the architecture. Traditional blockchain architecture is when all the transactions go into some pool where they are being extracted. If it is data, it is burnt into the blockchain directly. If it is a smart contract invocation, then it goes to some computation environment. It is being executed, and its results go down back to the blockchain. As I already said at the beginning, it is sequential execution, and the whole network with thousands of nodes just degrade to a single computer. We would like to provide true concurrency, true parallel execution, and utilize the all power of network that is available. Besides this, Color Platform will utilize a number of extra features, and as already Dr. Cho said, one of the features would be physical unclonable function for offline transactions. What is physical unclonable function? When a silicon chip is being produced on the factory, in theory, all the gates are the same. But in practice, there are some randomness in the doping of a semiconductor. So some gates, here they are marked as red. Red. They are not the same as others. They are open. So the factory expected them all to be closed, but some of them, while manufacturing, become open, and it is unpredictable. You can never predict what will be the output of real manufacturing. So every chip has its own unique set of closed and open gates. It is like a unique fingerprint. And this means that every chip could be identified, and it is unique. And no two chips have the same signature. And actually, our partner company ICTK from South Korea, they assure us that it is not possible to emulate using a computer program. So it is true unique feature. Every chip has a unique fingerprint, and it gives us an opportunity to create offline transactions. So what is the feature with current blockchains that are going to the world, such as credit card that is, not debit card that is connected to some blockchain? It means that every operation should go through the blockchain. So if you want, so in some sense, cryptocurrency is not a coin. When you have a coin, you just handle it to each other and say, oh, now you own that. In blockchain, every such transaction should be recorded. So there is always a third party, the network, that keeps the track of all operations. In 컬러플랫폼, we are going to make the color coin to be more like coin. So maybe not just a coin, but you bring two devices to each other, and they just exchange between them. And the feature here, the trick here, is how to avoid double spending, how to avoid fraud operations. So it is a work in progress. It is really a challenging task, but we are sure it's worth doing because it makes the, as Dr. Cho already said, physical and cyber world closer to each other. So we are bringing back the practice of money from the real world to the crypto world. Maybe you never realized how much trust you, devote to the banking system when you use your credit card. You trust to the bank that issued the credit card. You trust to the owner of the terminal, to the maintainer of this terminal. You trust to the network. You trust to the bank account of the seller. You trust to your own bank that all these operations go correctly and exactly the amount you paid is actually paid from your balance and the balance is updated correctly. And the seller is also trusting all the banks that this goes correct. In our system, we reduce amount of trust. We just say that this is, well, actually this is not trust. All the code will be open source, so community can evaluate security, safety, reliability of those systems. And the idea is that some of the transactions in 컬러플랫폼 could go offline. So like true coin passing from one hand to another. And actually, there is one more thing that should be considered. All I said was about running the apps. It is implemented, it is supported by the architecture of 컬러플랫폼. But the true challenge is not in the platform, actually. I would say that the true challenge is in creating the apps. Who knows CryptoKitties, the app? Okay, some of us. It was the first app that end users could benefit from. So it is not about signing documents. It is not about transferring money. It is not exchange. It is just a game of selling kitties, breeding kitties, and making new species. And in summer, in the spring of this year, it just ruined Ethereum network. There were more than 10,000 users playing with their kitties, breeding them, selling them, buying them, and the Ethereum network fell down. It was major success. There was a big hype of the apps, but nowadays, CryptoKitties has just 500 users, not 10,000, just 500. Even a gambling application have less than 1,000 users every day. If you look at the EOS network, that is proclaiming to be the fastest network in the world with dozens or hundreds of apps, most of the time they produce block with zero or single transaction. It means that there is a very challenging task to create new interesting apps for the ecosystem. So the second major task that is that we state for us for the 컬러플랫폼 is color development kit that supports rapid development of decentralized application. So color development kit is like a ground, like a soil that is giving strength, giving resources to producing all the environment, all the ecosystem, or the decentralized application for this world. So we are building a complex system that includes both the core for running the apps and the tools for building the apps. These two things cannot be separated from each other. If you just build a platform and say, hey, people, use my platform, it is cool, the experience shows that people don't come. So we need to provide tools, we need to provide incentives, we need to provide some clear understanding of what is the app, why it is useful, what are the benefits of creating the apps. So Color Development Kit will be integrated development environment with powerful tools to code. That's simple enough. With powerful tools for testing, that is much more complicated because any app is a decentralized application. It needs a special testing facilities such as including virtual machines, service nodes, ledger nodes, middleware to run it. Tools for unit testing, for integration testing. If you had an experience of writing the code for Ethereum using Solidity, you definitely know that there are no IDEs, there are actually no debugging facilities. Well, there are some, but they don't work. There are no testing tools, no unit testing for that. But without such a tools, development is impossible. It is just 60 years ago when the first mainframes emerged and new compilers emerged, there were no debuggers. But now, how can you even imagine development without such a tools for code production? And since we are targeting secure and safe decentralized application, one of our objectives, actually, blockchain is about security, but there are so many cases now that there are stealing money from wallets, stealing money from applications, stealing money from exchanges. Security is not in cryptography. Security is in code. So there is a very important thing is to provide the developers with the tools for security analysis, for safety analysis, for reliability analysis, and it is one of the major features of our platform that distinguishes it from all the rest, that we are thinking about this, and more or less we are planning to include such tools in our Color Development Kit. So thank you very much. And now I will give the stage to our partner from Minsk, Softtech company, to Artem. He will tell you a few more words about the Q&A quality assurance process that will be established in development of the Color platform.